In this episode, we turn to a reality that every serious learner needs to understand early. Releasing an artificial intelligence, AI, system into production does not prove that it will stay safe, reliable, or well-governed once real people begin using it in real conditions. A system may have looked solid during development and even passed pre-release checks, but the production environment adds complexity, pressure, unpredictability, and exposure that can reveal weaknesses nobody fully saw before launch. That is why organizations must keep assessing deployed AI after release through methods such as audits, red teaming, threat modeling, and security testing. Each of these approaches looks at the system from a different angle, and together they help answer a simple but important question. Is this deployed system still operating in a way the organization can trust, defend, and control? For a beginner, the biggest lesson is that post-release assessment is not a sign that the team failed earlier. It is a normal part of responsible governance, because production always teaches organizations things that design and testing alone cannot fully reveal. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To understand why post-release assessment matters, it helps to picture the difference between training for a sport and playing in a real championship game. Practice can be careful, controlled, and useful, but the real contest brings fatigue, pressure, unusual moves, unexpected weather, and opponents who behave in ways the team did not rehearse exactly. Production AI works the same way because the live environment introduces messy inputs, new users, shifting data, strange behaviors, conflicting incentives, and sometimes malicious attention. A model that looked stable in a controlled setting may become brittle when people rely on it heavily, challenge its boundaries, or use it in ways designers did not expect. Beginners sometimes assume that if a system passed testing once, then ongoing evaluation is mostly a formality. In reality, the production stage is where the system begins interacting with the organization's true operating conditions, and that is precisely where governance must remain active if the organization wants to reduce harm, detect weakness, and keep its decisions defensible over time. The word production simply means the system is live and being used for actual work, actual services, or actual decisions rather than being kept in a development sandbox. That difference matters because production use creates real consequences. A weak answer from a demo system may be a minor embarrassment, but a weak answer from a live customer-facing assistant, a live fraud screen, or a live decision support tool can affect trust, opportunity, privacy, safety, or operations. Once the system is influencing real outcomes, the organization must examine not just whether the software is still functioning, but whether the deployed system remains appropriate for its purpose. That includes how it behaves under pressure, how people respond to it, how it handles edge cases, and whether controls that looked strong on paper are actually working in practice. For beginners, this is one of the clearest shifts from development thinking to governance thinking. The question is no longer only whether the model can perform. The question is whether the live system can continue operating responsibly in the world it has entered. One of the most structured ways to examine a production AI system is through an audit. An audit is a disciplined review of whether the system, the process around it, or the organization's controls match what was promised, required, or expected. Audits can look at documentation, governance records, model limitations, user access, decision logs, approval paths, monitoring results, change management, incident handling, or compliance with internal and external obligations. The purpose is not merely to catch wrongdoing. It is to create a clear picture of whether the system is being managed in a consistent, accountable, and evidence-based way. Beginners often hear the word audit and imagine a cold inspection that exists only to assign blame. But a well-run audit can be a very practical learning tool. It can show whether teams are following approved processes, whether controls exist only on paper, whether known risks were properly tracked, and whether the organization still has enough evidence to justify keeping the system in production under current conditions. Audits are especially valuable because they check whether reality still matches the system's original governance story. Before release, Teams may document intended uses, limitations, approval conditions, human oversight requirements, and monitoring expectations. Over time, however, production systems often drift not only in data and performance, but also in how people use them. A system approved for one narrow purpose may slowly expand into other decisions. Human review may become weaker because staff begin trusting the output too much. Logging may degrade, documentation may fall behind, and changes may be introduced without the same scrutiny applied during the original release. An audit helps surface these gaps by comparing the live operating state against the approved design, policy commitments, and control expectations. For a beginner, the key idea is that an audit asks whether the organization is actually governing the system the way it says it is. That question matters because many failures happen not from the original model alone, but from the gradual erosion of discipline around it after it has become part of daily operations. Red teaming offers a different kind of value because it approaches the system more like an adversary, a skeptic, or a determined stress tester rather than a control checker. In red teaming, a group intentionally tries to make the system fail, misbehave, reveal harmful weaknesses, or produce dangerous outputs under realistic or creative conditions. The point is not random destruction. The point is structured challenge. A red team may probe for unsafe responses, manipulative behavior, prompt sensitivity, information leakage, brittle reasoning, policy bypass, or ways a user might exploit the system to cause damage. What makes red teaming powerful is that it does not assume people will use the system politely or exactly as intended. Beginners should understand that this is a vital mindset in production because once a system is public or broadly accessible, it will eventually be tested by curious users, impatient users, careless users, and sometimes openly malicious users. Red teaming helps the organization learn from that pressure before real attackers or harmful incidents expose the weaknesses first. A common misconception is that red teaming is only useful for highly advanced or obviously dangerous AI systems. In truth, even modest deployed systems can benefit from adversarial thinking. A customer support assistant may be manipulated into giving inaccurate policy guidance. An internal summarization tool may expose confidential information if it handles permissions poorly. A recommendation system may be gamed by users who learn how to influence outputs. A content moderation system may miss harmful material framed in unusual ways. The value of red teaming comes from asking uncomfortable questions early and systematically. What happens if a user pushes the system outside normal conditions? What happens if someone tries to extract information the system should not reveal? What happens if people deliberately exploit ambiguity in instructions? For beginners, the main lesson is that red teaming is not about assuming every user is an enemy. It is about accepting that responsible governance requires testing how the system behaves when faced with pressure, manipulation, and creative misuse rather than trusting only best-case scenarios. Threat modeling adds yet another perspective, and it is one of the clearest ways to connect AI governance with cybersecurity thinking. Threat modeling is the practice of thinking through what could go wrong, who or what could cause that problem, how the harm might happen, and where controls are weak or missing. Instead of waiting for an attack or incident, teams map out plausible threat paths in advance. In the AI context, threat modeling can include traditional security concerns such as unauthorized access, data exposure, and service disruption, but it also includes AI-specific concerns such as poisoning of training data, manipulation of inputs, abuse of model outputs, bypass of safeguards, model extraction, over-reliance by users, or harmful automation at scale. Beginners often expect threat modeling to be highly technical and narrow, but its core idea is actually very intuitive. It is simply a disciplined way of asking how a system could be harmed or misused, who would benefit from that harm, and what weaknesses make the system vulnerable to those pathways in production. Threat modeling is particularly important after release because the live environment often reveals new assets, new dependencies, and new exposure paths that were less visible during development. A system may now be connected to customer data, internal workflows, third-party services, and user-facing interfaces in ways that create new attack surfaces. The more integrated the system becomes, the more important it is to understand not just the model, but the full chain around it. That includes the data flows feeding it, the applications calling it, the people reviewing outputs, the storage locations holding logs, and the business processes that act on its recommendations. For a beginner, this is a crucial governance lesson. An AI system is rarely just a model floating on its own. It sits inside a wider operational environment, and many important threats come from the interaction between components rather than from the model in isolation. Threat modeling helps organizations see those connections clearly enough to strengthen the system before real exploitation or failure forces the lesson in a more painful way. Security testing is related to threat modeling, but it is more hands-on in spirit. Once a team has identified important risks, security testing helps examine whether defenses actually hold up under realistic conditions. Security testing can look at access controls, data protection, integration weaknesses, logging quality, abuse paths, resilience under stress, and the ability of the surrounding system to resist compromise or misuse. In AI deployments, security testing should not stop at the model boundary. It should extend to interfaces, supporting applications, infrastructure, data pipelines, and the workflows that determine how outputs influence downstream actions. Beginners sometimes think of security testing as something only traditional software teams need, while AI teams focus mainly on model performance. That split is dangerous. A well-performing model embedded in an insecure environment can still become a source of harm, because attackers may target the system around the model, the data entering it, or the privileges granted to services connected to it. Strong post-release assessment therefore treats security as part of overall AI trustworthiness, not as a separate problem someone else will handle. These four approaches are strongest when they work together instead of being treated as isolated exercises. An audit may reveal that change records are incomplete or that approved use boundaries have started to blur. Red teaming may uncover harmful outputs or policy bypasses that routine monitoring missed. Threat modeling may identify exposure paths that the organization had not previously prioritized. Security testing may confirm whether technical controls around those exposures actually hold. Each method informs the others. If red teaming finds a serious weakness, auditors may later check whether corrective action was recorded and followed through. If threat modeling uncovers a risky dependency, security testing can probe it more directly. If an audit shows that staff are bypassing review procedures, the organization may recognize that certain red team scenarios are more dangerous than originally assumed. For beginners, this combined view matters because governance is rarely about one perfect method. It is about building enough overlapping ways of seeing the system that blind spots become harder to ignore and evidence becomes stronger. Another important point for beginners is that these assessments are not just about technology. They are also about people, roles, and incentives. A production AI system may fail because users misunderstand what it should be trusted to do, because reviewers become too dependent on the output, because teams rush updates without careful assessment, or because nobody owns the decision to pause the system when warning signs appear. Audits can show whether responsibilities are clearly assigned. Red teaming can reveal how real users might manipulate or misunderstand the system. Threat modeling can include insiders, contractors, or workflow failures as sources of risk. Security testing can show whether access and oversight are properly enforced. This broader view is essential because many real-world AI failures are socio-technical rather than purely technical. The system may not collapse because the algorithm suddenly became nonsensical. It may fail because human habits, organizational pressure, weak process discipline, and technical fragility combine in production to create a situation nobody is fully controlling. Organizations also need to know what to do with the findings from these assessments, because discovering weaknesses is only useful if those weaknesses lead to action. Some findings may require a small fix, tighter guardrails, better monitoring, or clearer instructions for users. Others may reveal that the system should be limited to a narrower use case than originally planned. Some may justify retraining, redesign, or stronger human oversight. In severe cases, the correct decision may be to pause or deactivate part of the deployment until the risk can be reduced. Beginners should see that assessment is tied directly to governance decision-making. The goal is not to create reports that sit unread in a folder. The goal is to build a feedback loop where evidence from audits, red teaming, threat modeling, and security testing shapes real decisions about whether the system remains acceptable in production, under what conditions it may continue to operate, and what additional controls are required to keep its use responsible. There are also several misconceptions worth clearing away. One is the belief that a system that has not yet caused a public incident must therefore be secure and well-governed. Another is the idea that audits alone are enough because they provide formal review. A third is the assumption that security testing only matters if the system handles highly sensitive data. A fourth is the belief that red teaming is too aggressive or unnecessary for ordinary business deployments. These ideas all miss something important. Absence of visible failure is not proof of safety. Formal review cannot replace adversarial challenge. Security weakness can create harm even without the most sensitive data being present. Adversarial testing is useful precisely because ordinary business systems can still be abused, manipulated, or overtrusted in ways that damage users and organizations. For beginners, one of the best habits to build is intellectual humility. Post-release assessment works well when teams assume they still have more to learn about the live system rather than treating early success as permanent proof that the deployment no longer needs serious scrutiny. A simple example can pull these ideas together. Imagine a live AI assistant that helps staff review incoming customer requests and suggest next actions. An audit might check whether staff still follow the required review steps, whether decision records are preserved, and whether updates to the system were approved properly. A red team might try to force the assistant into producing harmful, misleading, or privacy-violating outputs through unusual inputs or manipulative phrasing. A threat model might examine whether attackers could abuse the request pipeline, whether confidential information could move through the wrong channels, or whether staff might overtrust the assistant during busy periods. Security testing might then evaluate the access controls, integration points, and logging around that workflow to see whether the organization could detect or contain misuse. None of these methods tells the whole story alone, but together they give leaders a much fuller picture of what production risk actually looks like. That fuller picture is what allows governance to move from assumption to evidence. As we close, the central idea is that assessing a production AI system after release is not optional busywork added to satisfy process. It is one of the main ways an organization learns whether the live system still deserves the trust being placed in it. Audits help verify that controls, records, and governance commitments remain real in practice. Red teaming shows how the system behaves under pressure, misuse, and adversarial challenge. Threat modeling helps teams reason through what could go wrong and where exposure truly exists across the broader environment. Security testing examines whether the technical and operational defenses around the deployment are actually strong enough to support the system safely. For a beginner, these methods are best understood as four complementary lenses on one problem: how to keep a released AI system defensible, governable, and resilient in the messy conditions of the real world. A mature organization does not assume production equals proof. It keeps looking, testing, questioning, and learning for as long as the system continues to matter.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.